All right, well, good morning, everybody. Thanks for coming. I have a lot of stuff to get through, so I'm going to kind of jump right into it. Hold on to your hats. I'm here to talk about, 3 decades and some of life in Kernelland. So, I mean, where else do you start but from this famous announcement from the Torvalds saying that he's starting a new system. It's going to be just a hobby, not anything big and professional like GNU was. Well, this is the plot of the size of the kernel over time, from the beginning till the recent past, to where we're up to just over 40 million lines of code at this point. So I think it's fair to say that indeed Linux has become big and professional. This was one of our early introductions to trusting the predictions that Linux makes. The thing I want to point out here, if you look at this line, it's really monotonically upward. It's always increasing. We're always building on the kernel, despite the fact that a lot of things were happening in the world over these 3 decades and some, right? We had the dot-com crash that happened in 2000. We had the SCO lawsuit. In 2008, there was the global economic crisis that created trouble across the planet. Then, of course, we had the COVID pandemic, which people will certainly remember. And if you look at this plot, you don't really see an effect on the development speed of Linux from any of these events. We have somehow managed to sustain everything that we do, despite all the stuff that has happened in the world. So I found this interesting, so I wanted to spend a little time talking about how is it that we did this? How did we get there? And what have we learned along the way? And to do that, I've taken as a theme this classic quote from Mahatma Gandhi saying, first they ignore you, then they laugh at you, then they fight you, and then you win. Well, obviously we start with being ignored, which is the period I see as happening from 1991 about to 1998. If you look at the initial kernel release, right, about 10,000 lines of code, it was missing a few sort of minor features like networking and a graphical interface and multiprocessor support, or support for anything but a basic x86 processor. This kernel was, in other words, it was a toy, right? It was something that anybody was justified in ignoring. You were not going to use this for real work unless your real work was playing with bash on a minimal Unix type system. But what happened here is a classic example of what was called by Clayton Christensen disruptive innovation, where the technology that ends up overturning the world starts out as something that's objectively worse than what you have currently. And so you ignore it. And it kind of builds up in the background while you're not paying attention to it. And all of a sudden you find that it has eaten your lunch. So Linux was ignored really as part of a function of this kind of phenomenon, and for a number of other reasons. The early 1990s were the end of the era where we thought that Unix was going to take over the world. Right? Unix had a good run, but then all the vendors each made their own version of it. They each made something that was bad in its own and different and incompatible way, and really balkanized that market and left a wide opening for something a bit more unified and a bit cheaper, which of course was filled by Microsoft. There was a lot to be heard in the early 1990s about how Windows NT was the future. That everything was going to be NT, not just desktops, but servers, the whole computing world was going to be Windows NT. And so anything else that came along just seemed almost irrelevant at that point. There was also still a perception in those days that the only way to do an operating system kernel was to be a big company. You had to be a Digital Equipment Corporation or an IBM or a Microsoft. A bunch of people working on their own time, just sort of throwing something together, couldn't possibly ever do this. So there was no reason to pay attention to all of that. So this kept Linux off the radar for an awfully long time, while in fact things were developing, while the community was growing, while we were getting somewhere. And this persisted until around 1998. So what happened in 1998, of course, was that Netscape gave up on the browser market, having lost that to Microsoft, and announced they were going to release the source code for their browser. Now, this was before the term open source had been invented. It was before people really understood anything about the concepts of open source development. And so the notion that a company would take its core product and do this really sort of took the world by storm. And once people started looking at this, they started looking around for other things being developed that way, and Linux was at the top of everybody's list, because Linux had come quite a long ways by this. So you had managers and companies asking their technical people, hey, have you ever heard of this Linux thing? Should we be thinking about it? And they found it running all over their institutions already, because the people who worked with the technology understood that here was something that was cheap, it was flexible, it was something they had some control over, could participate in, it was more fun. Right? They can install it without having to go through the company purchasing process and so on. And so Linux was really found to be running everywhere. And this drew attention to the development process. Now, Eric Raymond, for all of his faults, put his finger on something important, right? The way software was developed in those days was a very centralized model, what he called the cathedral model. This is true of proprietary software, of course, but it was also true of what we now call open source projects as well. If you think about the X Consortium, if you think about the BSDs, they were managed in a very centralized way, and you were either part of the group that was working on it or you weren't. And if you weren't, it was very hard to participate in the development of that. Linux was different. Linux had no pride. He threw open the door to everybody. And anybody who could send him a patch could participate. And so we would take it, we would throw away a lot of stuff that didn't work. It seemed wasteful in ways, but there were no boundaries. Anybody could be a part of it. It was a lot more fun, and it was a lot more open. And as a result, Linux developed a community that you didn't find in other open projects at that time. And that allowed it to progress in a much faster way, leading to sort of the first lesson I want to draw attention to, which is the development process really matters. How you organize your project, how you accept code, really makes a difference in terms of the success of what you're trying to do. Related to this is licensing and the choice of the GNU General Public License, right? This license, of course, requires anybody who distributes a modified version of a project to make their source code available under the same license. This keeps the code together. It helps to prevent forks. It helps you to have a unified code base where everybody is working on the same thing. In the early 1990s, the BSD systems were much more mature than Linux was at that point. They were capable of much more. They were much more usable. But the permissive model that was used there, along with other things, led to a whole bunch of forks. And there are now many BSD systems out there, none of which really gained the critical mass in terms of either development community or adoption to dominate. Linux instead, the Linux kernel stayed one thing. It stayed together for reasons we'll get into, and that I think helped it in many ways. The copyright policy, that everybody retains their copyright under the same license, has also helped. It means that nobody owns Linux, right? Or everybody owns Linux. It is not a company project. It's not something that somebody can pull out from under you. And that makes a huge difference. So, basic lesson, licensing does matter. Sometimes I think people have forgotten some of this in the rush to permissive licenses in recent times, but licensing does make a difference. Another aspect of the success in the early days, I think, was the fact that the kernel project focused just on the kernel. That made it different from BSD, for example, where you get the whole package. You get the kernel, you get the user space, you get everything managed under one roof. Linux was just the kernel. All the other stuff, the user space utilities, the creation of distributions and an actual working system was left to other people. That allowed innovation to happen in parallel in a lot of different places. I think that the distribution model of Linux is one of its real strengths. It has allowed us to experiment on how to build systems and to learn a lot in the process. So, common lesson in the software world, modularity really does speed development, speeds innovation. And the separation of the kernel project here, I think, has made a big difference in that regard. One last thing I want to point out too. How many people here have heard of Beowulf clusters? A fair number, actually. Beowulf clusters emerged in the mid to late 1990s, and the idea that if you take a bunch of really dirt cheap commodity computers, you stick Linux on them, and then you connect them with the fastest network that you can get, what you get is a supercomputer. And this idea took off in certain areas and was widely ignored in others. Right? I worked in a supercomputing center when this was happening. And I went to them and I said, hey, we should really be looking at this. And they said, no, we have these crays over here, and that's really all that we're ever going to need. That really didn't age very well. Now, the thing is, people don't really talk about Beowulf clusters anymore for a simple reason, which is we call them data centers now, right? This was the origin of all these massive systems that are now driving our commerce and our AI and everything else, was these ratty little racks of computers in university labs in the 1990s. So anyway, they stopped ignoring us, and we get into the phase where they start to laugh at us instead. And they did. They did. We had, ads from Microsoft poking fun at the sort of amorphous nature of the Linux system, and people laughing about how, no system developed in some kid's parents' basement is going to do anything for us or anything like that. We had, at that time, high-profile industry analysts saying, sure, promote it to your boss, but you may get fired as a result of that. We're still working. I don't think he is. We're better off for it. But not everybody was laughing. And one of the key events in the development of Linux was when Intel announced that it was going to announce in Red Hat. This was the first real acknowledgement, the first real acknowledgement that Linux was here to stay, that it was being taken seriously in the industry, and that there were going to be resources behind it. And then IBM came along and said they were going to throw $1 billion at it, and that really just drove that home as well. That all of a sudden, it was something to be taken seriously, maybe not laughed at, maybe to be looked at. And this started the whole sort of engagement between the Linux kernel and companies, which, I could do a whole talk on that. But we started with Linux developers starting to get jobs working on this, which is something that didn't happen early on. There were a lot of concerns about that. Some of these developers just disappeared in the companies, a lot of them early on. We got better about that. We had companies adopting Linux for their products, not so many of them giving back in the early days, although we worked on that and got better about that as well. But we were seeing some interesting things. I got to play with what I believe was the first embedded Linux product ever, which was the Axis camera. We had people talking about Linux-powered telephones. Now, in 1999, this seemed like a pretty exotic idea. I venture that many, if not most of you, have a Linux-powered telephone in your pocket now. This was our highly professional booth at Comdex around 2000, right? But the point being that Comdex created an open source ghetto off to one side where we could all be, sort of towards the end of Comdex. It started to snowball and started to grow and kind of came to a peak with the initial public offering of VA Linux systems, which generated quite a bit of laughter in its own right. VA Linux systems, of course, had the biggest single-day price increase, opening day price increase, of any public offering to that date. And so a lot of people looked at it and said, well, that's ridiculous. This stuff isn't going to go anywhere. With regard to VA Linux, they weren't too far off, but with regard to Linux as a whole, they were. But this was really just a kind of one of the bigger symptoms of the fact that we were at the final days of the dot-com bubble. And the final days of that turned it into the Linux bubble, where suddenly Linux was hot, and if your company could somehow say it was associated with Linux, there was a lot of money being thrown at you in various ways. There were startups happening everywhere. There was money falling from the skies. Someone I know who worked at VA said that they bought a very high office space so that everybody could see the pile of burning money from far away. So, all this stuff is sloshing around. It looks like we're going to be all doing really wonderfully. But of course, it was a bubble. And it popped, and suddenly all of that money was gone. A lot of those companies were gone. A lot of what was going on was proved to have no real basis in reality. Certainly nothing like that's happening today. But in any case, this led to a whole new set of discussions about how do we actually do something that's sustainable around Linux and all that? How do we keep this stuff going when we don't have money being thrown at us from all directions from people hoping they'll get rich next week? But let me remind you of this plot, right? Much of the commercial structure around Linux self-destructed over the course of about a month in 2000. But development of the Linux kernel did not slow down. Nothing really changed there, which was perhaps the first object lesson of of this point here, which is that Linux truly is independent of any of its corporate patrons. Like, almost everybody who works on Linux is paid to do so, but there's no one company that dominates this. There's no one company, the loss of which will seriously damage the development of the Linux kernel. Right? We are independent of all that, and this has served us very well over the years, because the companies that are working on Linux have changed quite a bit over the years, but the kernel itself persists and continues to just go from strength to strength. One other thing I want to point out during this phase, in 2001, this was the very first kernel summit. This was the first time that many of these developers had ever met each other face to face, after having been working together for about 10 years. And there were some interesting things that came out of it. I mean, we, of course, accomplished quite a lot in the discussions there, much more quickly than we could all that. But we really came to the realization that seeing each other face to face matters, right? That in-person meetings are important, because we are a large global community. We work electronically, but if we can get together every now and then, share a beer, talk about our problems, we understand each other in a way that we don't if we just stay dispersed across the planet. And that makes the whole community work so much better than it does otherwise. And the community has taken this to heart. We do a lot of meetings over the course of the year, perhaps even too many. But this is an area of concern at the moment. Regardless of how you might feel about the current policies of the current US administration, it is objectively true that those policies have made a lot of people unwilling to travel to the United States for conferences or for anything else. I mean, that is simply observable in the statistics and so on. And what that has done in turn is make it so that there will be no core development conferences around Linux and other things in the United States in the foreseeable future. It's just not going to happen here. And this is a real problem. And some of us are fortunate enough that we can travel internationally so that we can be at this. But not everybody can do that. And there are a lot of people in the United States, visa holders and such, who are under advisement from their employers or their universities not to leave the United States for fear of being able to get back in. So they are now cut out of this. So we have lost a part of something that holds our community together and makes us efficient. And I don't really know how we're going to observe this. I hope we can get past this and get to a point where we can all meet all over the planet again. Anyway, enough said about that. So the last thing I want to talk about in this phase is the release front. If you look here, these are the major stable releases that we made during this time. And initially, it was taking us about a year to put out a stable kernel release, which is a little while, but it's okay. But it was getting longer and longer. It was getting to a point where it's taking us like 3 years to make a kernel release. And this was getting to be a real problem during a time when Linux was taking off, but we had a lot of problems to solve. So people were starting to worry about it. What's happening here is that we were starting to see some of the scaling problems in the process. I said the process matters. Our process was starting to not work so well. And key to this was the fact that every single patch that went into the kernel had to be emailed to Linus Torvalds, who would then apply it himself. And it got to a point where he just couldn't keep up with it. Nobody would be able to keep up with it. And so we had a lot of kind of scary episodes where things broke down. Things weren't working. The fact that we had no source code management system, of course, did not help with this at all. Now, the seeds of the solution to this were actually planted many years before. I had, back in 1998, had a conversation with Larry McVoy about a system he was calling BitKeeper. Right? He had a different view of how source code management should work, where it was done in a distributed way, where everybody had their own repository. What he called lieutenants, what we now call subsystem maintainers, would maintain their own repository for the piece of code that they had responsibility for, and then feed the result up to Linus so that he didn't have to look at every patch individually. And this would all make the current status of every repository always visible and really kind of smooth out the development process. There's just one problem, of course, with BitKeeper, which is that it was not free software. And this didn't sit well with people in the community. There were a lot of debates about it and all that, but we tried it anyway. So starting in February 2002, with the 2.5.4 development release, we started using BitKeeper, and a lot of things improved right away. We managed to smooth out a lot of our scalability problems, make the process work better. Other problems had to be solved later. I'll come back to those. So that by the end of this phase, right, we'd stabilized the process a bit. The 2.6 kernel was finally out. The commercial side of Linux was growing, and people weren't really laughing at us anymore. So what comes next, of course? They started to fight us. We had, Steve Ballmer ranting about how Linux is a cancer that attaches itself to everything it touches. We had the Sun CEO saying there's no place for Linux in the server. That's his turf. A lot of these things did not age well. But we had fights on different fronts as well. The WRT54G was a small home router that was built around Linux with a whole lot of modifications to the kernel to make firewalling and other things work better. Linksys and then Cisco that bought it did not release the source to their changes as the license required them to do. It took a lot of fighting in courts and elsewhere to finally get that code released, at which point it was integrated into the kernel, made part of the kernel that we have for everybody, and now you really can't find a network router that doesn't run Linux, right? And that was all a part of this. It was all a part of how the licensing worked to make the whole process work better and keep code together. So once again, the licensing really does matter. If Linux had been permissively licensed, it would not have proceeded this way. But of course, the big fight during that time was when this company called the SCO Group decided that they were going to file suit against IBM, right? They made the claim that millions of lines, literally millions of lines of code from the Unix system, which they claim to own, which is a whole separate amusing story, had been copied into Linux. And so as a result, they essentially owned Linux, and IBM owed them $5 billion. So this cast a bit of a pall across the community and the industry at the time. All these companies working with Linux were wondering, well, what have we built our future on here? Developers wondering if they were going to have a project to work on. And this lasted for a while. But the simple truth of the matter is that it made us stronger. And at the core of it is the fact that we were attacked by idiots, right? I mean, it was a clown show in a lot of ways, but first of all, they had no case, right? And they presented it badly, and they decided to attack the very hardest target in the industry that they could possibly have gone after. They could have caused a lot of damage if they had pursued it differently. But there were a couple of lessons that came out of this. During this whole process, the Linux source code was examined under a microscope in a way that I think no other software project, free or commercial, ever has been before or since, right? There were billions of dollars at stake here, right? There was a real incentive to find these millions of lines of copied code, and given that there were so many, it shouldn't be that hard to do. There was nothing, right? There was nothing. What was made clear is that people who were working on Linux aren't there to steal code from somewhere else. They're there to solve problems and to make the best system they can. The code base was clean. It was really sparkling clean, cleaner probably than just about any proprietary code base you could have looked at that time. And as a result, nobody has really contemplated a copyright-based lawsuit against Linux ever since, right? This point has just been made so clear that nobody has ever worried about that again. But there's also this point that was made that we hadn't really understood before, that if you create something that is of value, somebody sooner or later is likely to try to take it from you. And so you need defense. You also need to be able to deal with little things like international sanctions and patent law and all that sort of stuff. You need lawyers. We didn't really have them when this came about. We got them pretty quickly and have them now. And it's kind of unfortunate to have to do that. Programmers tend to hate it because we think we can look at the legal code the way we look at software code, and they're just not the same. We need them. All right, meanwhile, internally, remember I talked about BitKeeper and how it had improved the development process. 3 years later, we were fully dependent on it, right? It made everything work so smoothly that everybody was using it. The process, as I said, was completely dependent upon it. So, problem being, of course, that it remained non-free software, and there were ongoing flame wars and such, and disagreements with its developer who wanted to monetize it in other ways. And so this came to a head in April of 2005 when that license was abruptly withdrawn. And overnight, we found ourselves without the software tool upon which we had built the entire development process. So this brought everything to a halt, and we're all kind of sitting there looking at each other saying, now what? Well, lasted about a week. And then Linus Torvalds went off for a weekend and came back with Git. And of course, it took a little while. But then we were back in business, and in fact, working much better than we were before after a while. And not only were we working better, but much of the rest of the software development world was as well. So a lesson that I think that we have often been slow to learn in the kernel community is that the tools really matter. We really need to pay attention to and invest in our tools. Remember, this is a community that operated for 10 years without a source code management system at all. But whenever we do focus attention there, we get back way more than we invest in it. But the other lesson is this. If you build your project or your company or whatever on proprietary software, you're building on sand, right? You're building on something that somebody else can yank out from underneath you at any time. And it happens. It happened to us. We saw it. This is a lesson we have taken to heart, and we have really avoided this kind of situation ever since. So, end of that phase, the final phase, where we win. But of course, we hadn't solved all the problems yet. We still haven't solved all the problems. But there were a few things we still had to work through, one of which was still the development process. We were still figuring that out. We had this model where we would do odd-numbered releases that were development releases. You throw in all the features you can, break it in any way you can, and then eventually try to stabilize it and put out an even-numbered release that would be the thing that people were actually expected to use. And so that model led to this chart that I had put up before of a slowing trend towards getting our releases out. We were having a hard time doing it. There are a lot of reasons for this. Right, if you're stopping development and just trying to stabilize it, what you end up with is what's people called patch pressure, where you have a lot of code that's developed, it's working, it's ready to go in, but it can't because we're trying to stabilize the kernel to make a stable release. And so people end up sort of sneaking things in, the feature freezes get unfrozen, and so on, and then you still can't stabilize it, and you delay things further, and it didn't work very well at all. And if you look at another line on that chart, it appears that we were continuing in that trend, right? It's 18 months after the 2.6.0 release came out, we were at 2.6.12. We still had not released the 2.7 development release. But the fact of the matter is that the situation had changed by then in an interesting way. Several months before, at the 2004 kernel summit, when we got together, and one of the topics to discuss, one of the key topics was, when are we going to start 2.7? And the answer that came out that surprised just about everybody in the room was never. Right, there would be no 2.7, and in fact, there never was. Instead, we adopted what we called then the new kernel development model. Now it's just the kernel development model, where we got rid of that even-odd process and instead said we would make every release into a stable release. We would put new features into every release, and we would try to do them quickly so that we could get the code out to users as quickly as we could. So it took us several years after that to really work this out, but this is the way the process works now. Right, where the first 2 weeks of every development cycle are what's called the merge window, where all the new code, the new features go in. Then for the following 7 or 8 weeks, we stabilize it. We fix things, whatever problems that come out, deal with the integration problems, that sort of thing. And then we make a release, and it's done. And this works well enough at this point that every release takes 9 or 10 weeks in total. You can set your clock by them. In the last 15 years, there have been exactly 2 exceptions. Right, which I've listed there. And if you look at what caused those exceptions, right, 4.15 was delayed a couple of weeks because we had to integrate massive changes to deal with the disclosure of the Meltdown Inspector hardware vulnerabilities. In 2011, 3.1 was delayed because kernel.org was broken into and we lost our main development platform. That is the seismic scale of the events it takes to delay a kernel release at this point, because we've managed to get this whole process down working smoothly enough. So obvious lessons: integrate your changes quickly, right? Don't say, okay, it's ready, but you have to keep it out for a long time. It just doesn't work. And get that code out to the users as quickly as you can. And that leads to a process that works a whole lot better. Now, of course, I can't really complete this without mentioning the stable updates, which is the other important part of the process, because these are the kernels that we actually run. Right? These are kernels that are maintained after the major release happens, that have fixes applied to them, and as you can see, a lot of fixes applied to them. Right? By the time one of these kernels goes out of maintenance, it can have 30,000 fixes applied. Right? It's a lot of fixes. Right? It takes us a long time to fix all the problems, and we're still fixing 20-year-old bugs and all that turn up after that long. It's funny how it takes a long time to actually really stabilize things. And you have to bear that in mind, but you have to do it in parallel with the feature development, right? The two have to work together. First of all, the feature development finds a lot of the bugs, and you fix those as you go. But you can't slow down the feature side of the house while you're doing the stabilization side. You really have to do both together. So we've figured out how to do that and made things work much more smoothly as a result. So I'm running a little slow. The last thing I want to say on this topic is that also at that meeting, Andrew Morton gave an important talk where he implored the vendors working in the area to not do their differentiation at the kernel level, to work commonly on the common kernel and to do their differentiation elsewhere. The industry really took this to heart, leading to the upstream first policy. And that, I mean, there's some notable exceptions to this, of course, but it has, in general, worked very well for us. Now, the key event, 2007, hardware support was a big problem for us for a long time, getting companies to support Linux on their hardware. In 2007, one of the biggest problems, which was graphics drivers, was resolved and really kind of opened the door for a lot of things, driving home the lesson that patient engagement with companies really does, in the end, pay off. I mentioned the kernel.org break-in in 2011 led to a lot of concern about what could have happened. All that wasn't as bad as it could have been, but it drove home the lesson that you really do need professional support for your infrastructure, right? If you've got a project the size and scale of the kernel, you cannot maintain your infrastructure with a couple of developers doing it on their spare time, which is what we were doing before. So every big project needs to keep that in mind. Final thing I want to point out here, just an interesting case study that I think is worth mentioning. In 2004, the first real-time preemption patches were posted. This was an effort to turn the Linux kernel into one that could provide true deterministic real-time support, something no general-purpose kernel had ever done and which people swore could not be done. Last September, the final pull request for this project was delivered. In fact, it was delivered by hand. Right, 20 years later. And the point I want to make really is that we can do these long-term projects in a way that few projects and few companies really can. And this is really a result of our process, of the fact that the kernel has its life independent of any company or any other sort of entity like that. Not that many projects can sustain a project over that period of time. We do many of them. And so then you get to the phase where then you win. And so we are here, right? Linux is everywhere. We put out about 6 releases a year. We involve 4,000 to 5,000 developers every year and have about 80,000 commits, more than that, coming in every year. Things are running pretty smoothly. So it's all perfect, right? It's not, of course. So I wanted to mention just a few things in closing about areas of concern, starting with the conduct and diversity. Now, I think that the kernel community does not really deserve its Wild West reputation. 20 years ago, maybe more so, things have gotten a lot better since then. And we, in fact, have a really respectful community now. But, you know, in truth, This is a picture from the 2024 Maintainer Summit last year. And what you see here is a bunch of nice people, but not a very diverse community, right? We all kind of look the same. We even all dress the same, except Thorsten, but he's weird. We're clearly missing out from the input, the wisdom, the effort from a large subsection of humanity still. And I think this is a serious problem. I think we really have to work harder at resolving that. I'm not sure how we're going to do it, but I think we really need to do that. Maintainer support. We have been very good at convincing companies that they need to give back to Linux. What we have not been very good at is telling them that giving back isn't just contributing code, that we need to support the process and various other aspects of it. So a lot of the people doing the maintenance work in Linux are doing it on their own time or on top of a lot of other tasks. A lot of the maintainers in the kernel project are suffering. This, of course, is not unique to the kernel. This is endemic to free software development in general. So we really need to continue to push on our employers and everybody else to improve their support for the maintainer function, or we are going to see problems and more GIATAN type episodes and that sort of thing if we don't properly support our maintainers. I have said in the past that we have underinvested in tools a lot. We've gotten a little bit better. We have better testing infrastructure than we used to, and various other things, some efforts from the Linux Foundation that are good. But we need to do a lot more here. Everything we invest in this area pays back many, many times over. And I wish that more of the companies involved in Linux saw fit to invest in that aspect of it. And then my final thing, which is perhaps better news. In 1991, C was probably a good choice to build a kernel with. In 2025, I don't think anybody would do that. So I'm really glad to see the progress that the Rust for Linux people are making. It seems to be accelerating quite nicely. And I think that if you come back in 5 or 10 years, you're going to see a very different looking kernel source base. And I think that's really important for our sustainability, both in terms of the quality of the code and the developers that we attract. And with that, I'm out of slides and just about out of times and out of voice, but I can certainly take a question or two if anybody has one. Or if I put you all to sleep, we can stop here. All right, there. Do we have a microphone for the questions, or just ask? I'll repeat it.
Yeah. So, does the Linux Foundation have any plans for putting salaries on certain maintainers that work on stuff that no company wants to directly hire for?
Well, of course, I do not represent the Linux Foundation, so I cannot. Let me say that the Linux Foundation does at times go out, and the way this works is usually Jim Zemlin going out and rattling a cup and saying, I need you to support this particular function. And so he has done that. That's how kernel.org got supported, for example. And Greg Kroll-Hartman, the stable maintainer, is supported that way. But the Linux Foundation does not employ a lot of developers, right? Their efforts are done mostly elsewhere. They are supporting some effort on tools, which is nice. But the maintainership support, I think, is mostly going to have to come from somewhere else.
I hope you write a book someday.
Yes.
So,
I wrote a book someday. That was a while ago.
I think a lot of us live this. I remember agonizing over the SCO lawsuit, trying to convince my boss, having to write a justification why we're using Linux instead of Windows. It was galling and it was frustrating, and you had to live through all that, and it was cathartic to watch you lay it all out. So thank you very much.
Thank you. It was fun to do. Yeah.
How do you forgive Microsoft?
That's a serious question.
It's a serious question. Like,
How-
I work in certain companies, but they do great work right now. But there's still an emotional aspect for people of a certain age and older, where, how do you do that?
How do you forgive Microsoft? Companies are psychotic adolescents. I mean, seriously, right? And they're quite variable, and they have their moods. And, having raised kids, If I couldn't forgive Microsoft, I couldn't really forgive my kid either for some of the things they did. But, I also, while it was my responsibility, kept watching closely. Right, Microsoft is friendly now. They're doing good things now. Tomorrow that could change, as with any other company that supports Linux. Stephen.
Yeah, actually, to follow up on that, Linus and I talked about that Saturday, and because you probably know, Bill Gates and Linus Torvalds actually met and had dinner, and they had a good time. Read all about it. I've written just, but anyway, and specifically to that question, he said, it's fucking over. I didn't quote that part. And Microsoft and Linux rivalries are long past. He's forgiven them. If Linus can forgive them, I think we can.
I mean, we have had.
Yeah, that's another thing.
Daryl's still out.
Daryl's still on. No, Daryl died.
Yeah, we'll not speak ill of the dead. But I mean, we've had so many, at times abrasive encounters with so many companies, many of which are now the biggest supporters of Linux. So, you have to kind of give everyone time to come around and become a part of our community. In the back there first, and then.
So we have some notable exceptions that are not living upstream on the kernel here. Part of their value add may be tooling and testing. That they have the ability to verify this kernel is ready for the customer. Isn't that a weak spot for the kernel going forward, where we're dependent upon these companies that have the secret sauce that keeps those bugs covered?
Are we dependent on companies for tooling and testing in particular? And yes, a lot of the testing is done in these companies. I mean, like a lot of the development is, right? It's distributed. So yes, we are dependent on them to do this work, but we're not dependent on any single one of them. I mean, I would sure like to see more of it. I would like to see more of them making their results more publicly available. But I'm not concerned about the testing that's done there. I think it's an important step beyond what we had before. It's a step in the right direction. All right, last one.
Yeah, it's interestingly, I think, kind of in parallel with a recent question. But one of the lessons we learned is that Linux has a life that's independent of corporate patrons. And of course, I believe that was one of the slides or something like that.
Right.
And of course, we still also want to have that funding for maintainers and stuff like that. How do we go about balancing that sort of like independence and making sure that we can continue to work while also having that sort of maintainer sponsorship?
Yeah, how do we maintain our independence while working with corporate sponsorship?
Yeah.
And I think really our key strength there is the diversity of it. Right. Any given kernel release has input from over 200 companies. So, and the biggest one and most recent releases tends to be Intel. Right. From what I'm hearing, that may be about to change, unfortunately, just from public rumors of layoffs coming there. But Intel has contributed about 10% of the changes to recent kernels, which makes it by far the biggest of the contributors to recent kernels. If we lose them entirely, first of all, a lot of those developers will find jobs somewhere else. And in any case, we still have the bulk of the community there. So, that I think was given us that monotonically upward line that I displayed at the beginning, right? Is that diversity of support from so many places. So I think that as long as we can maintain that and we don't become owned by a single company, which I think we never will, I think we're in good shape. All right, well, I need to get out of the way for the next speaker. I thank you all very much. If anybody else has questions, we can ask them outside the meeting.